R is this value. I don't know if you agree.
Yes, sir.
Okay, because the value of R is the distance between the centers. So we have 182,619.8 times the value of MB. We got the value which was 29.99. So the value that I got is 5,476 767.8 meters. So that's the value we're talking about. Now, in order for us to calculate the distance between the surface of the planet and the object, what should I do, Ronel?
Would the surface, or the distance between the surface and the object, would it not be, so I'm just thinking maybe it would be the R, the value of R minus the radius of the planet.
That's true. 1, 2, 3. So this will be 5,476 7.8 minus 3 3340 1 2 3. So the value that I got is 21,3676 7.8 meters. That's what I got. Yes. So I just want to ask, Ne, what if the value that I got was a negative? What would that mean?
So what did you say, sorry?
The value that I got was negative. The value of X that I've got was negative. What would it mean?
Oh, so I'm not sure.
It would mean that the object is in the ground. It's inside the ground. I don't know if you agree.
Oh, okay, that's possible.
Yes, it is possible. In case if you get such questions, don't panic because calculations are calculations. If the value of R is less than the radius, it means the object is in the ground. It happens. They may give you such questions. So if you get it, please don't panic. Okay. No problems. Okay. The last one says, hey, what's happening to my pen now? Okay. The last question says, if the mass of the planet was greater than that of 3.4.2, will the value of gravitational acceleration increase, decrease, or stay the same? Give the reason for your answer. If the mass of the planet was bigger than the one we have calculated, will the gravitational acceleration be larger? Will it increase, decrease, or stay the same?
So I'm guessing it will decrease.
Why is it going to decrease 3.4.5? Okay. Why do you think it's gonna decrease the gravitational acceleration?
So I was gonna say something like the acceleration is inversely proportional to the mass.
I think you are inventing a new gravitational law. I see. I see that you are challenging Newton, but it's fine. You said inversely proportional. Okay, this is inversely proportional.
The acceleration
Okay.
is inversely proportional to the mass.
Is it the okay? Acceleration is inversely proportional to the mass. That's what you just said. This is what it means. This is inversely proportional.
Yes.
Oh, okay. Can you please redefine, okay, or give me the formula for calculating G?
So G is equals to Gm over R squared.
Is it inversely proportional? If the value of M increases, does the value of G increases?
No.
It doesn't.
No, sir.
Okay. I'm gonna make this very easy. Let's just assume that the value of G is 1 and the value of R squared is 1, right?
Okay.
Okay. We will have 1 over 1 squared, then times, let's say the value of mass is 1 also, right?
Yes.
What are you gonna get? What are you gonna get?
1.
1. So let's just say this is what we had initially.
Yes.
And then after the show, the mass increased. That's what they are saying.
Okay.
The mass increased, the G stayed the same, and the R squared stayed the same. We'll have 1 over 1 squared times, let's say the mass increased by 1 and it became 2. So we are going to have 2. What is the answer?
2.
2. Okay. Did the value of gravitational acceleration increased or decreased?
So it increased.
It did increase. It did increase. So I just want to teach you something that is very vital when it comes to dealing with equations and the whole proportionality definition. If you have an equation, G equals Gm over R squared. The fact is, everything that is in the numerator for any equation, everything that is on the numerator is directly proportional to your subject of the formula all the time.
Yes, sir, that makes sense. And
the value of G as well. If the value of G somehow was increased, your value of gravitational acceleration was gonna increase. And if it is decreased, also the value of small g will decrease. The same thing if the mass is decreased, it is going to decrease. The meaning of inversely proportional is that whatever that is in the denominator is inversely proportional to the subject of the formula. That is why these equations are called inverse square relationship. So the R squared is an inverse because it's on the denominator.
Yes, okay.
So,
I just assumed that both of...
no.
Yeah, I was wrong to assume. Sorry, sir.
Yes, and okay, let me ask you a quick question. If the radius or the value of r increases, if the value of r increases, what happens to the value of g?
Does it not decrease?
It does decrease because the relationship is inverse. It is the opposite.
Yes,
You
sir.
agree? Okay. Let us try to answer the question. Let me erase everything which is irrelevant. I was trying to show you how it is. This is wrong. G is directly proportional to M. So if M increases, then your G will increase. That's correct. That's perfect. Okay. So do you have any further question from what we've been doing?
No.
Okay, so I'm gonna try to send all the workings that we have done so far, so that you can see where you went wrong and where you didn't. And on the next lesson, we will be doing multiple choice questions.
Okay, sir.
I'll be doing and how how are you finding physics so far in class?
So we haven't really had we are exactly where we left off because we had a physics experiment to do. So
Okay. And the experiment, what was it all about? Is it
so
Newton's law?
so the yes, but yeah, the experiment was based off of a ticker timer. So we had to calculate the distance and the speed and the net force, and then I still have to complete questions like you know other questions. But it was based on the experiment of the ticker timer.
Or you have another question?
No, sir, I'm good.
Oh, okay. I thought you have another question. No, before we end, I just want to ask you a few questions. What is weightlessness?
So weightlessness is the sensation experienced when all contact forces are removed.
When all contact forces are removed. Okay, that's perfect. Can you give an example of a situation where you have weightlessness?
So you're cutting. I can't hear what you're saying. Can you please repeat that?
Okay, can you give an example of
Yeah.
where this weightlessness?
Um. So so okay, if an object is placed in a isolated system or in a I want to say vacuum, so it means that that object isn't affected by all the external forces.
Yeah, that's correct. That's correct. So that's another way of defining weightlessness. Under weightlessness, however, let me reshare the screen. I just want to show you the examples, some examples where you have weightlessness. Okay. Okay. Can you see the screen?
Yes, sir.
Okay. In a lift, you can have weightlessness. Okay. If a person is inside the lift and inside the lift, if you put a scale to measure the weight, ne?
Yes, sir.
When the lift is when the lift is not moving, Fg will be the weight on the scale.
Yes, sir.
You agree?
Yes.
But when the lift starts moving, because the scale measures the normal force. Do you agree?
Yes, sir.
The scale measures normal force.
Okay, so basically what you're saying is that if the lift were to go upwards, the normal force would increase, or the weight would increase. And if the lift were to go downwards, it would the weight would
weight on
decrease.
this. Yes, yes,
Okay.
that's true. So you can make they can even give you a question in the exam to say if you measure weight inside a lift when the lift is moving upwards, will that measurement be a correct measurement of weight? And the answer is no. Right? Giving
Yes,
the
sir.
reasons that you have given me. Now, what happens when the lift is in a free fall?
Yes, sir.
When the lift is in a free fall, what is the value of the acceleration of the lift? When the lift is in a free fall, when there's no force pushing the lift, when the lift is just falling, what will be the value of G on the lift? The gravitational acceleration.
So I want to say 9.8.
But
Wait. Yeah, so I want to say 9.8.
yeah, but there's something preventing you to say it.
So what is that?
Because you said you wanna say.
Okay, so I'm saying 9.8.
Okay, 9.8. I agree with you. I agree with you 100%. Okay. Now, what will be when the man is in a free fall? What will be their gravitational acceleration?
So would it not also be 9.8?
It will be 9.8. So let me ask you, if the lift and the man are accelerating in the same acceleration, will we have a contact force? Are we
If
gonna
the-
have a normal force?
If the lift and the man have the same acceleration,
Yes.
we have a contact force. So I'm guessing not.
Give the reason.
So because no, so I actually want to change my answer. If there, so actually I don't know. I'm changing my answer to I don't know.
The answer is there won't be any normal force. Let me give you an example. Ne? Let's say if do you have a sister?
Do I have a sister, Yuta?
A younger sister.
Yes, sir.
Okay. Let's say your younger sister decides to come and take away food from you quickly, and then starts running.
Yes, sir.
And then you follow her. And if she tries to accelerate, and then if you yourself try to accelerate, and she tried to accelerate in the same acceleration that you are accelerating, will you be able to catch her?
Yes, sir.
If you're accelerating in the same acceleration, there's no way you're gonna catch her.
Okay, so you say she started running first.
Yeah, let's say even if she starts running slow, but let's say even if you are in the same, let's say if you are 1 meter apart,
Yes. Oh, so
and
I won't catch
and
her.
then you accelerate, and as soon as you accelerate, she accelerates in the same way that you're accelerating. Will you be able to catch her?
No, I won't be able to catch her, sir.
So it's the same thing with the lift and the man. So if the lift is moving in the acceleration of 9.8 and the man is moving at an acceleration of 9.8, there won't be any normal force. The man
Yes.
won't catch up to the lift.
Yes, sir.
So the force on the scale will be 0.
Yes, sir.
Okay, so when the force on the scale is 0, this is what we call weightlessness. The man does have a mass, but there is no contact. There won't be any contact. They won't catch up to each other. The man and the trolley, and the lift, or the man and the scale, they won't catch up to each other until the accelerations changes. But at the time when they are both moving with the same acceleration on a free fall, that's what we call weightlessness. The scale will read 0.
Yes, sir.
Okay. So yeah, I was just giving you another example of weightlessness, which you may find in the exam. You may find in the exam. So if you get it, please don't panic. If we get another question of this type, I will do it with you guys in the next sessions, possibly before you write the exams. Okay, so I think that's about it. We are running out of time. We'll see you guys on Thursday.
Okay, sir.
All right. Enjoy.
Bye, sir.
All right.